Hello all, I'm Yogi Singh. Welcome to my YouTube channel, Yogi's Data Lab. Today, we are going to see exactly how we'll use the matrix method to solve a linear regression problem. So we can solve linear regression problem using matrix method, and we'll compare the results of this matrix method with solving the same problem statement with Sklearn. And we'll see that the results that we get using the matrix method as well as using the linear regression model using Sklearn method, both of them are giving me the same results. So let us see how exactly first the mathematics behind this is solved using matrix method. And after doing this, we'll go into Python and we'll see how the results are evolved using the matrix method as well as using Sklearn. Okay, so let's begin. So uh, we say that our error is nothing but y minus y cap whole square. This is my squared sum of errors. Now, if you remember the equation of linear regression, y is equal to beta 0 plus beta 1 x1 up to beta n xn. Ideally, it is not y, right? It is the predicted value. Whenever I get this equation, I can go ahead and predict anything. So I can say that y cap is equal to beta 0 plus beta 1 x1 up to beta n xn. So I can write this expression epsilon is equal to y minus beta 0 plus beta 1 x1 up to beta n xn whole square. If I write this in a matrix form, let us say I write this as y1, y2, y3 minus I'll put as x1, 1, x1, 2. So these are on my independent variables, x2, 1, x2, 2, x2, 3, x3, 1, x3, 2, and x3, 3. And then I put my beta equation, which is beta 1, beta 2, beta 3. And I can give this as a square. But there's one thing which is missing here, which is beta 0. So if you remember the stats model, which we discussed in one of our videos in the case study, we used to add a constant, right? What did that constant do? It used to add a column with values 1. So if I go ahead and add that constant and put a beta 0 here, this will give me the complete equation. So when you're solving this matrix, what is the result that you are going to get? You are going to get something like y1 minus beta 0 plus beta 1 x11 plus beta 2 x12 plus beta 3 x13. That's when you're solving the first one. Then the second line will become y2 minus beta 0 plus beta 1 x21 plus beta 2 x22 plus beta 3 x23. Then you have y3 minus, you'll get beta 0 plus beta 1 x31 plus beta 2 x32 plus beta 3 x33. So basically I can see that I have the equation for every single record in my data set when I'm solving it this way. So I've just written it in this form. Now this I am going to represent as y. This is my X matrix and this is my beta matrix. So I can say that epsilon is y minus x beta whole square. Now the important thing over here is the data that you get. Let's say this is your data set, okay? So you have your x's and you have your y. When you have your x's and your y, these things are constant, right? This doesn't change. This is the data which you have received. This is not going to change. Nothing is going to change here. So y and x is constant. If I want my errors to be minimum, the minimum amount of errors that I can get is 0. The only thing I can play around is with the beta. By diminishing the value of beta, I can reach to a 0 error. So how do I do this? Let us say I do d by d beta of y minus x beta whole square. And what is the minimum amount of errors that we can get? That is 0. So this will solve to minus 2x y minus x beta equal to 0. Now there is a slight trick here. Let's try to see that. So if you try to understand beta, we'll go with these order of these matrix. So if you look at this matrix, it is a 3 cross 1 matrix. This is a 3 cross 4 matrix because we added one more column over here, and this is a 4 cross 1 matrix. A product of 3 cross 4 with 4 cross 1 will give me a matrix of 3 cross 1. And since this y is of 3 cross 1 and the resultant is of 3 cross 1, I can do the subtraction. Now let's look at this. If y is a 3 cross 1 matrix, x is a 3 cross 4 matrix, beta is a 4 cross 1 matrix, and x is a 3 cross 4 matrix. So this is a 3 cross 4 matrix. Now what do you see here? This will result in a 3 cross 1, and the output of these two will be 3 cross 1. This is a 3 cross 4 matrix, and this is a 3 cross 1 matrix, which is in a dot product over here. So this cannot be multiplied. But if I do this as a transpose, if I put a transpose on X, what will happen? It will become a 4 cross 3 matrix. And now the inner orders of the matrix will match, and the resultant matrix will be a 4 cross 1 matrix. So what we are going to do here is, rather than going with X, we are going to make it X transpose. So let us go ahead and do this. So the result that we are getting is minus 2x transpose y minus x beta is equal to 0. When you solve this, what you are going to get? You are going to get minus x transpose y plus x transpose x multiplied by beta is equal to 0. So x transpose x multiplied by beta is x transpose y. So beta is x transpose x inverse x transpose y. So what we are going to do now is we are going to create these matrix. We have x, we have y. We are going to create a transpose, do a product, take an inverse. We'll do x transpose y and get the final result. And that will give me the values of beta 0, beta 1, beta 2, and beta 3. And then we are going to compare these results with Sklearn linear regression. And we'll see if the beta that we calculated using the matrix method is the same that we are getting using Sklearn linear regression. So this is the matrix form which we are going to use. Okay, so here is the case study. So I've taken the same case study for which I have built the video for linear regression. Here I am trying to predict the price of home. And these are all my variables which are contributing towards my price. So price is my target variable. I have area, number of bedrooms, number of bathrooms, stories, main road, guest room, basement, hot water heating, air conditioning, number of parkings available, is the property in a preferred area, and the furnishing status of that house. I'm importing my libraries, and I'm not using all the matrix. I'm just using R square and root mean squared error. I'm reading my data set, creating a copy, looking at the head. So we see that this is my target variable, which is in a larger scale. And I have all the other variables which are pretty clean. So I'm not doing any feature engineering much here or much of things. I'm just comparing the actual with the predicted. So I'm trying to solve that using a matrix method. If you are looking into how to solve this problem statement in a better way, there's another video, which is where this case study is solved. I'll share that link in the details section. You can go and have a look at that. So when I look at this, I'm preparing my independent and dependent data set, creating my dummies for all my independent data sets. So I see I have everything numeric. I'm splitting my data into train and test. And now, since my data is ready, what I'll do is I will start with the matrix method. So let's look at this. So what I'm doing here is I'm adding a constant. So if you remember, we added once in that set of x's. So I'm adding a constant here. I am doing a multiplication of the X matrix transpose with X. Right? So I'll just write that equation here for you to understand. So we had beta, is equal to X transpose X inverse X transpose Y. Now let's see this. So when I'm solving this, what I'm doing, this is my X matrix. I am taking a transpose of this. So this becomes X transpose. And I'm taking a dot product with X. So X transpose X, I'm solving this part. Now I'm doing an inverse of this. So X transpose X inverse, this is the part I have solved over here. Now I'm also taking a dot product of X transpose Y. So this part. X transpose Y. So here I am taking a transpose of the matrix. Here it is my Y and I'm taking a dot product. And now the final product is of X transpose X inverse with X transpose Y. So X transpose X inverse with X transpose Y. Whatever is the value that you're getting in the beta, this is it. You see, these are the values which we'll get after solving this matrix. Now, let us go ahead and see when we solve this same data set with Sklearn. So I'm just creating an object of linear regression and fitting it on the train set. I go ahead and calculate my intercept. So you see the intercept that is coming is 73,195.27, which is the same that you got here. This E04 means multiplied by 10 to the power 4. So if you multiply this by 10 to the power 4, you'll get the same value that you are getting here. Then this is your beta 1, beta 2, beta 3, beta 4, and so on. Here you are getting beta 1, beta 2, beta 3, beta 4, and so on. We'll compare the results. So this code is just to compare the results. If you look at the values, these are the values which we got using matrix calculation. And these are the values I got using the Sklearn model. You see the difference is 0. Some places you see -0 because in a larger decimal value, maybe there's some difference, but most of the decimal values up to 4th decimal place, I see the values are 0. So what does this mean? It means that either I solve this problem statement using the matrix method or I solve this using Sklearn linear regression. Both of them are going to give me same result. So this was the mathematical understanding of how a linear regression algorithm runs behind the scene using matrix method. I hope this video helped you clear a few more concepts about machine learning. Please don't forget to like, share, and subscribe this channel. We'll see you again in the next video. Thank you for watching.